Hello everyone, my name is Danish and you're watching Codenotes. In this tutorial, we're going to reverse a snake game using IDA Pro. It's a free game that I found on GitHub. We're going to reverse the 32-bit exe file. The main point of this video is to see how C++ code looks like in assembly and how we can reverse it. Let's open the game in IDA. When we open a file in IDA for the first time, IDA will analyze it. This may take a few minutes. Once IDA is done analyzing the file, it is very important to save it so we don't lose our progress. We can see in the output window, database has been saved. This is the entry point for the program and it is executed first. Press F5 to decompile the function. This code will make sense when we name the functions and variables. I will open the functions so IDA can properly identify the number of parameters. It looks a little better now, but we still have work to do. Before we begin reversing, let's go through some important shortcuts. In the pseudocode, I can click anywhere and press the tab key. It will take me to the exact assembly instruction in the IDA view. If I press tab again, it will take me back to the pseudocode. We can also press spacebar to change the view. Pressing spacebar again will show us in this nice readable way, where we can look at the arrows and see which part of the code executes depending on the condition. For example, if here the E6 register is not 0, then the control jumps to the code with the red arrow. Otherwise, it jumps to this part of code. Shift F1 will show us the local types. This is where we can see all of the structs and enums. IDA allows us to define our own types. If I want to add a new type, I can click on Edit, Insert and add a new type. We can write the type in C, which makes everything a lot easier. We can also insert an enum in the same way. Shift F2 will show us a script window where we can write IDC or Python scripts. IDC is the scripting language of IDA, but I personally like to use Python for scripting. It's very helpful when we want to automate some very time-consuming tasks. The output window at the bottom also allows us to execute scripts. Shift F3 will show the function names list. This is where we can see all the functions in the executable or the library. These names are not the real names of the functions. These are assigned by IDA to uniquely identify them, as IDA doesn't know the real names. Shift F4 will show the names window. The names window contains all function names, but here we can see all of the global variables and the visual function tables. This is also known as RTTI, which stands for Runtime Type Information. It will tell us the actual class name. If I click on one of the visual function tables, we can see the addresses of the functions in the table. Shift F9 will show the structs table. We can also add structs here by going to Edit and inserting one. Shift F10 will show the enums window. Shift F12 will show us the strings window. This is where we can see all of the strings used in the program. So let's start naming. Lucky for us, we can compare this with the source code. This is the snake game variable. I'm pretty sure it's this one. To name a variable, click on it, press N and type the name. The type of the variable can be changed by pressing Y. We don't need to change it for now, and we will save it again. This is the constructor of snake game app class. Whenever we declare a class instance variable, if the class has a constructor, then it is called first. In our case, snake game app class has a constructor, so it is called immediately after declaring the class instance variable. Now we can name the constructor by going to the function, click on its name, and press N. Let's call it snake game app constructor. In the source code, we can see that when the constructor is called, then the run function is called. This code comes from the exception handler. We now know what it is, so we can ignore it. I'll name this variable SEH. It is for the exception handler, so we don't get confused. Since this is the run function of the Snake Game app class, we can name it as well. As usual, we'll save our progress. We can see that the code is now making sense, but we still need to do more. The rest of the code in this function is related to the exception handler, so it's not really important to us. We can just ignore it and move on. We're only concerned with the important part of code, like this function and this one. We can go to the constructor and see that a lot of things are happening here. For example, in the source code, we can see that as soon as the constructor is called, then the constructor of GameWindowMember variable is called and hence it is initialized. The type of GameWindowMember is renderWindow. So the constructor of renderWindow is called on this member variable. Let's do the right thing and give it a good name. I will name it renderWindowConstructor. And don't forget to save the progress. We can exit this function and go back to the previous one by pressing the escape key. Now we'll go into the run function. This code is very hard to read for now, but when we add structs, start naming the functions and variables, it will be readable. We'll start by naming the functions. The type of GameClock variable is a class, and the clock class has a constructor defined. So the constructor of the clock class will be called for the GameClock variable. So let's name it sfClockConstructor. The variable v1 contains a copy of this pointer, so let's name it bthis. This is the GameWindowMember variable. The isOpen method is called on the GameWindowMember variable. The type of GameWindowMember variable is renderWindow. Let's name this function to sfRenderWindowIsOpen. This is the processAllEvents function of the Snake Game app class. We will save our progress again. The restart method of the clock class is called on the GameClock variable. Here the program is checking the value of the current state member. Click on bthis variable, press Y, and change the type to int. This will tell us the exact offset. If I change this back to char pointer, it will show a different offset because of the casting to dword pointer. So let's change it to int. I can right click the offset and change it to hexadecimal if I want. Let's copy this offset and add a new struct for Snake Game app class. We can click here and pressing D for the first time will add a new member. Pressing D again will change the size of the member. If we want to delete a member, we can click on it and press U. You might be wondering, what does the size mean? dB means defined byte. So dB is 1 byte. dW is defined word. So the size is 2 bytes. dd means defined double word. So the size is 4 bytes. We'll set the type to dB so we can define an array of bytes. Click array and write the offset here. We can see that at the bottom it says 224. The hexadecimal representation of 548 is 0x224. Now we can define the current state member. Let's check the size of the member. We can see that this pointer is casted to dword pointer. This means that the size of the class member is 4 bytes. So we'll set the size to dd, which is 4 bytes. Let's rename it to current state. If I copy this, click on this pointer, press Y to change the type, paste the class name here, press OK, and IDE will improve the readability of the pseudocode. This is the game window parameter. It is located at the offset 8. Let's add it to the class struct. We press Y again on this pointer variable and press OK so the changes can take effect. This is taking a lot of space in the window. We can define a byte array for it. There we go. IDE is showing that the restart method is taking an extra parameter. This extra parameter is actually the return value. In the 32-bit assembly, the return value is stored in the EX register. If the size of the return value is greater than 4 bytes, then it will use an extra parameter to make up for the size. The update current state method shows that it takes SF time as a parameter. That means that the restart method of the clock class returns the time. So here the second parameter is a pointer to the time struct. We can give this a good name. I can click on the restart method and press X. Pressing X will show all references to this function. We can go back to the run method. Let's add a struct for time. This is how the struct looks like. So let's define it. It has only 2 members. When we add the struct from here, then we have to import it by clicking on it. By the way, we can also right click and edit structs if we want. We can click on v9 variable, press Y and change the type to sftime. We can rename this variable to outtime. And rename the variable with return value to ptime. If the return value of the restart method is being passed as a pointer in the second parameter, then what exactly is the restart method returning in the EAX register? Because we know that the return value is stored in the EAX register, it's returning a pointer to the outtime local variable. It doesn't need to return anything, but the compiler chose to do it and it has the freedom to do so. So ptime variable contains the address of outtime local variable. Change the type of ptime to sftime pointer. We can see that the two members are being copied to some local variables on the stack. This means that we need to change the type of v11 variable to sftime. The current state member is being copied to v4 variable. The type of current state member is a pointer to game state. Now we have to define a new struct for the game state class. Right click here and create. Click at the bottom and press D to add members. Pressing D on the added member will change its size. The game state class has virtual functions. So the first 4 bytes are used to store a pointer to the virtual function table for the class. Now we create a new struct for the virtual function table. Press Shift F4 to open up the names window. We can search for the game state VF table. This is the VF table or virtual function table for the game state class. Let's compare this with the virtual functions in the source code. If we count the number of virtual functions in the VF table, it shows that there are only 5 virtual functions in the VF table. But if we look at the source code, we can see very clearly that there are 7 instead of 5. The thing is that the compiler optimized the code. It generated inline code for functions that were small to make the code execute faster, and did not create functions for them. It is very common for compilers to align functions that are small in size, so it doesn't have to call the function and this executes the code faster. The first 3 functions are pure virtual functions. That means that they don't have any function defined for them in the base class. And if any class inherits from GameState class, that class must override these functions. From my experience, virtual functions will appear in the order they are defined. This is the process next event method. This is the update method. And this is the render method. If you click on this function, it shows that it is an empty function. It returns nothing. This means that this is the doState change delay method. Press the escape key to go back. From what I know, the compiler will hardly ever align the destructor. So this means that the last method is the destructor. And these 2 functions have been inlined. So we are not seeing them in the VF table. If we go to the last function, we can see that it has some code for releasing memory. This confirms that it is a destructor. We can click on the function name and press N to name it. And as usual, we save our progress again. Let's finish our VF table struct. Click on the VF table member of the GameState class. Press Y and set the type to GameState vTable pointer. Add the next state class member. Create a new struct for the 2D vector class. Two-D vectors usually have x and y coordinates in games. The type can be either unsigned int or floating point. And finally, we add the window size member. Now we go back to the pseudocode and change the type of the current state member by first clicking on it and then pressing Y. And we also have to change the type of the variables. We are almost there. Let's name the variables. In the source code, the run method doesn't return any value. So let's change the return value of the function to void. Click on the function, press Y, and change the return type to void. Now the code is much more readable and we can easily understand what is going on. It may seem that as if a lot of functions from the source code are missing, but that's not really the case. The compiler inlined the functions because they were small. If you look at the hasStateChanged method, in the pseudocode it has been inlined. At the end of the loop, the updateStateChange method is called, and it will call the reset method on the current state member. The type of current state member is GameState wrapped in unique PTR. So calling the reset method on this member will assign the new state and delete the old GameState instance by calling its destructor. Let's reverse one more function. By looking at the source code, we can easily tell that this is the poll event method of the render window class. And this is the close method of the render window class. I have an IDA plugin installed that allows me to flip if-else statements. For example, if I right click here and flip this if-else statement, the logic at the top will also change. This will only work if there is an else block present in the pseudocode. This plugin can be downloaded from GitHub and the installation is very simple. Just copy paste everything into the plugins folder, which is located in the installation folder of IDA Pro. And then restart IDA Pro. Change the type of the this pointer to Snake Game App Pointer. This will make the code somewhat readable. An event struct is being passed to the poll event function in the second parameter. Then it sets the struct data and returns a pointer to the struct. Let's see how the event struct looks like. The event struct has a lot of enums, but we should not get distracted by them. We only care about the class members or enums used in the source code. The name of the first member is type, and the type of this member is an enum. We can add this enum to our IDB file in IDA Pro. We can also add an enum from the enum window. It is completely up to us, and IDA is very flexible. We can also edit the enum by right-clicking it. In the pseudocode, we can use this enum to make the code more readable. We can see that the second member of the event class is a union. That means depending on the event type, different structs can be used without the structs using too much data. In our case, we already know that the key type is used from the union in the source code, so we can just define the key struct for the event. From the source code, we can easily tell that it's checking for the escape key code. We can add the key code enum. We also need to write the value. We can right-click the value and choose hexadecimal. It will tell us the hexadecimal value for the number. We can go back to the enum and write the correct value. In the pseudocode, right-click the value and select SF keyboard enum. After setting the values, it is very important to save the progress. And now we add the event struct. We saw that it contains only two values. The first one is the event type and the second one is the data. But we already know that the data is a key event. By going to the local types, we can easily insert a new struct for the key event. and then we import the struct. Set the type of the key member to key event. Since we know that the v4 variable is the event, it is meant to hold the return value in the source code. So we change the type to SF event. If we compared this to the source code, it looks pretty much the same now. We can also flip the if statement if we want to, rename the variables, process all events method doesn't return any value in the source code. We can change the return value of the function by first clicking on it and then pressing Y. Now the method is completely reversed.